So here is one way of answering the question. What is the probability that my next coin toss will land heads is? Suppose one says, well, just look at the past frequencies. So someone could just say, look, there have been many, many coin tosses in the past. Just measure how many of those have been heads and let the current objective chance of heads just be the total number of heads divided by the total number of coin tosses. So probability of heads is just Can anyone think of a problem with that simple account?
This probably won't be very accurate when the total number of tosses is a small number.
Exactly. Exactly. So here's an example to dramatize that. Suppose that at some MIT lab, we managed to synthesize a previously unknown element. And in fact, we've only been able to create one particle of this new element, and it decayed after 43 minutes. So does that mean that the probability that the next particle created is going to decay in 43 minutes is 1? Of course not. We just don't have a good enough sample. Now, there is another problem with this case. And it's a problem that is fatal even if we have large samples. The problem is that part of what it is for an event to be chancy is that it could have occurred otherwise. So if you have a particle whose objective chance of decay in 8.9 seconds really is 1/2, then it's the case that really the probability of heads is 1/2. But that's compatible with this being the case, that the coin always lands heads. It's compatible with being the case that every single time our particle decays in less than 8.9 seconds. Of course, it's extremely unlikely that that will happen, but it's nonetheless possible. So although this recipe would give us a very good way of guessing at what the probabilities are, it wouldn't be a good way of defining what the probabilities are, because the definition would fail in these very unlikely cases.